Hello and welcome to the HTM Hackers Hangout. This is the first HTM Hackers Hangout of the year 2017. So congratulations. You made it through 2016. Pat yourself on the back.
Barely.
So I didn't have a huge plan for this, but yesterday and this morning I decided I was going to write up a year in review. And Subutai liked it, and most of my job is to make Subutai happy. So I'm going to share my year in review with you guys and just kind of run over what I think the highlights have been over this past year for the community, things we've got done. So this is in addition to any research stuff that we've worked on at Numenta. That has really been our focus this year. And so there was a big shift from applications to research, and there's a bit of overhead involved in that. But in addition, even with all of that, we've done some significant things. So we've got Windows builds. Okay, I have to start my little mouse effect. There we go. Windows builds for Nupic. We have also moved all of our Linux builds away from Travis CI and onto Bamboo. This will give us flexibility in the future to run everything on Bamboo. That is the goal at some point in the future. We can also say that our C++ algorithm suite is complete. So in Nupic Core, you have everything you need to run an HTM system. That also means that if you want a Ruby HTM, you can make it. So get to it. Make a Ruby HTM, make a JavaScript HTM, get crazy. You can create bindings, and if you need help with that, please contact anyone in the community. I've been sort of wondering when someone was going to say, hey, I want to write Go bindings or whatever. So let me know. Another significant thing that David Ray really put a lot of work into was getting HTM Java running the Numenta anomaly benchmark. Actually, HTM Java and Comport Text are both represented now in the NAB leaderboard. So I think it's great to have these community HTM systems represented on our leaderboard along with Nupic HTM. A couple other major things is we moved from mailing list to forum. So if you're still on the old mailing list, you're not getting much email, are you? That's because we shut them down. So if you're watching this wondering why you don't get emails, then join the 21st century and come to discourse.numenta.org. That's the new forum software. Additionally, we had a couple of community integrations come up this year. One of them from Aaron Wright, who's been in our community for a while. He created a Flink integration with Apache Flink, which is a streaming data architecture that's really cool. And that is using HTM Java under the hood as the HTM processor. And I also created an integration with InfluxDB, which is a time series database that can expose the data.
You've got feedback.
How can I have feedback? I don't have headphones on.
Yeah, you sound fine from where I am.
Okay.
I hear 2 out of sync Matts.
I'm sorry. I'm sorry to hear that.
I can turn my mic off just in case I'm the reason.
All I'm noticing is that my mouse highlighter is going in and out, in and out. I don't know why.
2 Matts.
Sorry about that, David. Moving on, Marcus, who's in the office right now, with some help from Andrew Malta, one of our interns, made a bunch of algorithm performance improvements. I won't go over all of them, but if you want to see them, there they are. There's a bunch. So I don't know exactly how to characterize this speed up, but I think he touched it in a lot of different places and made it faster in many different ways. So if you haven't used Nupic in a while, don't be surprised if it's a lot faster, because I've noticed, and that's awesome. Also, HTM Studio is a product that Numenta has created. And we did this so that anybody that's got data that could get into a CSV could run it through HTM and get anomalies from it. So it makes it really easy for non-programmers to get their data into an HTM. I have to figure out how to turn this mouse highlighting thing off because it's awful. Stop it. Okay. And of course, HTM School. So a lot of my time this past year has been creating this educational video series. I'm going to keep making it this year. I think that's a good summary of what's been
Oh
happening.
my God, that's like a 6-minute delay.
David, do you have a background tab open with this video that is like the streaming version of this video?
That may be it.
I think that's what's going on.
Okay. Okay, David, we're just gonna have to ignore you because everybody else I think is okay. Hey, Sebastian,
Hello.
can you hear us okay?
Yeah, I can hear you.
I can hear you, yes. Awesome.
Good.
All right, so sorry, David.
Sorry, that was my fault. You're right.
Okay, cool. Well, at least the problem is fixed. So that was the year update I wanted to do. But I was happy to see it. You know how I got that list is I went through all the HTM Hackers Hangouts for the past year. So we've been doing them for a year now. And I just kind of went like double time through them and perused and got this list of things that we'd accomplished over the year. So it's pretty cool, I think. So good job, everybody who helped out with that stuff. I appreciate it. A couple other things before I open up to the floor for just general discussion. I will be pushing in this month, we'll be pushing some Numenta.org content changes on our Numenta.org website. So that's going to change its look and feel completely. Nobody really seems interested in Numenta.org content, so I didn't really open it up anything to the community because I don't think you guys care. But it's going to be simpler, I think, and better than it is today, and it'll better be integrated with the Numenta.com sort of footprint. So that's going to be coming this month. We're also trying to continue improving deployment scenarios, especially for NuPick Core and NuPick. We do want to get to a point where it's fully automated, push button deployment, but we're still a ways from that. It's complicated with all the we have to wait for deployments to happen for it to get done, and then finally run another build and wait for all that to happen. But we're still working on it. Scott and I are going to be talking about priorities for the coming year. We haven't had that discussion yet, so we'll just update the community about what the priorities are. My community priorities versus Scott's more project-oriented, NuPick-oriented priorities. So we'll be communicating that over the next month too. So that's all I have, ladies and gentlemen. I'd be happy to open it up for any conversation if anybody wants to chat or ask questions. We're here for you. So. It's nice to see you, Sebastian.
Thank you. Can you actually see me on the webcam, or
no,
is it just
but
my picture?
Just your picture. But that's better than nothing. Honestly, nobody succeeds at Google Hangouts the first time. So
no, that's not true.
Well,
we hacked your webcam. We're looking at you sitting in your underwear.
I have to say, I'm really looking forward to working with your visualization library in Viz. I think the stuff you put out there looks really cool. So I'm going to be using it over the next month. I haven't gotten around to really digging into the temporal memory yet, but I like the way, and Marcus did this too. In your visualizations, you kept it all sort of as one-dimensional as possible. So you don't show a topology that doesn't exist. I think that's sort of important because I always assumed when I was looking at that stuff that whenever it was displayed three-dimensionally or two-dimensionally, that it was a two-dimensional structure. So I like how both of you guys in your visualizations really kind of line it up in a one-dimensional way and show how it, those connections in that fashion. I think it's clear for what the algorithm's actually doing.
Yeah, I feel that's the clearest way to visualize it, especially the connections between the cells. I found that's the most clearest way to visualize that. I've tried doing a bit of 3D, but again, the connections are not quite as clear as I wanted them to be.
Yeah, and I've been messing around a lot, with the, what's it called, 3JS, but I don't think I want to try and do the 3D visualization when there's no reason to. I think there should be communicated in 2 dimensions, I think. So.
I mean, part of
Yeah,
it
it
a good hard
doesn't
try.
really grant any, better information to give it an extra dimension.
Right, because you can see, I mean, Vision is inherently two-dimensional. You can see everything with 2 dimensions, but you add the third, and it's not like that causes you to see anything else. It just causes things to be
Right.
other things.
Totally.
Yeah, I've only found it necessary when there's topology. I think it really explains that.
I was just about to say it worked very well when you're explaining topology.
Yeah, but for all the TM viz I'm going to do at this point, I'm going to do it all two-dimensionally. So maybe I can just run this by you. I'm thinking about sample input to pass into the TM so that I can show it sort of working step by step. The very, very simplest thing I could do is, send it the results of a coin flip. Subutai mentioned this in the forum earlier today. I thought that'd make a really easy, simple starter example so that we can see it making predictions for both of them, at the same time. And over time, because it's random, they're going to be 50-50 over thousands of runs. We should be able to extract that from the system pretty easily. But I want to start really simple before building up more complicated temporal examples.
Yeah, it's better for people to grasp it if we start off simple and then build up each concept layered on top of the other.
Yeah.
I think you should do my Monday through Sunday days of the week thing, because I'm not sure a coin flip won't show you how certain columns are prioritized. I mean, I don't understand how that would really illustrate anything except that that it's capable of making simultaneous predictions equally with probably equal permanences for both sides of the coin, or for SDRs representing both sides of the coin.
That may be too contrived an example, but I'm trying. But we'll see. I haven't even dug into it yet, but I want to have something very simple initially.
Yeah, I found using that days of the week thing because I could see I could recognize the SDRs coming out of the spatial pooler, and I could see a gradual alignment or bias
what were you sending
columns.
What do you mean the days of the week thing? I'm sorry, I don't remember.
The little test program that you helped embellish over the summer when we were doing the NAB debugging, the Monday through Friday, Monday through the days of the week.
But that's actually using an encoder, right? Or were we?
Yeah. I mean,
so I'm going to go I'm not even going to use encoder. I'm not even going to use spatial pooler. I'm going to send bits directly into the temporal memory. Just that simple.
Well, you have to have distinct, inputs, right, to the TM.
Oh yeah, I mean coin flip.
Right.
This half's on or the other half's on.
Okay. All right.
Something like dead simple, just dead simple. I mean, I'm going to start there and try and get something maybe more interesting. But the point is to express how it's working. So if I can use a coin flip to express some of the very low level concepts, then it might be useful. Because I've tried this before. I've tried like splitting the input space into like 7 or 10 sections and just going blip, 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 repeat, blip, 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 blip. And then every once in a while introduce like a skitter, so one of them happens out of order randomly, and I can show that pretty easily. When it gets to the point where it might split, you can see that really easily. It's suddenly unsure about what the next step is going to be. So I want to get to the point where I can explain why that is happening.
Right. Right.
Anyhow.
Well, that'll be interesting.
It will be interesting. I'm looking forward to it.
Are you planning on using the really simple example we use quite often, ABCD and XBCY, and show how?
I have to. I think I have to. But even if it'd be nice if I can express that in a little bit of a richer medium than just characters. But that exact concept has to be expressed somehow.
Right.
But maybe I can express it a little bit better, because I don't want to encode strings or categories. It seems like I could make my own little thing to do that. That's just a category, right? I'll figure it out.
So where are you, Matt? Do you have some padding or something behind you? Do you have a sound booth now in your house?
Well, sort of. I have some sound suppression panels on my garage door.
Oh, okay.
So that helps.
I
But
saw
this
the
is-
squares in the material behind you, and I thought it was a solid wall.
It's just a cloth that
Ah,
I've
okay.
been, because I record in the garage, so it's
Okay.
nicer to have that than you get to see that.
Right, right. So Marcus, do you want to continue our conversation about the portability of upcoming sparse matrix oriented algorithms as opposed to the regular temporal memory algorithms? I mean, how
Right.
portable?
Like at the core, the change here is the fact that it's using a sparse matrix is kind of an implementation detail. The important thing is that
Okay.
that there are a set of batch commands into the connections class. In this case, our connections class is the sparse matrix, and we're making a bunch of batch calls on it to change synapses. So this could be equally well implemented as a few new methods on the connections class.
Oh, okay. All right. So it's just a storage mechanism. It's
Yeah.
not. It doesn't impact the way the algorithm it progresses. Or
Correct.
okay. Okay.
Right. I mean, it will. I'm thinking it will hit the random number generator in a different order, but it's,
Right.
otherwise, it's just the way that it's all. Basically, it's removing loops from the algorithm and it's moving them into the data structure.
So when you collect matching or active segments, they're marked inside of the sparse matrix instead of collecting a list. Is that it? And so I don't know. I don't know. I'm just off the top of my head just talking crap, but I don't know. I don't know exactly, how you would eliminate the loop from the algorithm itself. You just say, give me all of these.
Yeah.
Give me all.
Everything as a series of
Right.
vector operations of
Okay.
given this list of cells,
Right.
convert it to a list of columns by dividing.
Okay. Okay.
And just doing a set of operations like that. And so inherently what it's doing is more complicated. It's doing more computation, but
It's doing it in C.
yeah, a vast majority of it's happening down in C. So that makes it
Right.
faster.
Okay. All right.
Much
All right. Right.
So
Okay.
I would say you wouldn't get nearly as much speed up from it in Java than we do in Python, because in Java you're not paying the dynamic overhead with every time you add two numbers or do this dot that. It's
Right.
much faster in
Right.
Java already.
Right. Right. And then everything's compiled down anyway. So, I mean, on the fifth or sixth run, yeah. Okay. Yeah. Cause I've seen Java. I've watched my little test algorithm, and then, I've seen it go, and then like the fifth line through, all of a sudden it goes,
Oh yeah.
it takes off.
Yeah.
It's like, wow, man, that it really does inline all that crap and do all of the optimizations. Yeah. You can see it happening. Okay. All right. So, and then I want to ask you about what's the whole concept behind this delayed thing?
Oh, sure. I could talk about that a little because of the time
Okay.
I've been working on it.
Right.
The idea is in the networking.
Well, first explain what it is we're talking about to everybody.
So delayed links. Okay, sure. I'm not sure what angle to come at this from. In the
Okay.
network API gives you a lot of ways to hook up a bunch of different nodes, you could call them. We call them regions, which we don't like calling them regions, but that's what they're called. And so
Yeah, they're layers, by the way.
Yeah.
Okay, but go ahead.
yeah. And you have these inputs and outputs between them. And so you can connect inputs and outputs via links. And so every basically time step, each node, each layer, each region, whatever you want to call it, runs a computation, and it puts its output into its output. And then the links play the role of passing the outputs between nodes into each other's inputs, concatenating them together, and all of that kind of thing. So the work that Vitaly did that he's added to it is the ability to add a delay with like one node writes to its output. And then the next time step or 2 time steps later or 3 or whatever number you customize, that's when the other node receives it. So that gives us the ability to add in time delays inherent to the network. So if you don't do that, then it's kind of in this weird state where if you have nodes that are like kind of codependent on each other, then one of them will run. We're not running it in parallel. So one of them is going to execute before the other. And you're going to have this weird thing where one of them gets the current time steps input, one gets the previous. It's all just kind of messy. And we want to have time delays. That's kind of part of our algorithms. It's part of the temporal memory. Like unmyelinated axons inherently are slower, and so they're to want to model time delays. So, and this is putting that at the level of the network API.
Okay. All right. That's interesting.
Something I want to say about the network API. I think node is the right term, and it's super overloaded and super generic, and that's good because we don't know what's in an HTM node. It may be a region. It may be a layer. It depends on how you architect it.
I like the word node. We also happen to use nodes as well. Like a region has nodes in it, but we don't actually use that. So that's what makes it a little confusing to use the word node, but that's all details. But yeah, I agree. Node would be the best word.
I mean, the network API is architected in a way where you could have a node that contains another network, right? So, I mean, I think that'll happen eventually in the future.
So have you thought about being able to combine nodes in a functional, like in a functional graph, like you would do, say, Spark nodes and be able to do operations? Because then you could do all sorts of things like zip or delay or, combine and take from each, combine latest, add, subtract, and or, all sorts of things to the output, given that the currency between the nodes would be SDRs. You know what I'm saying?
I haven't spent much time thinking about
right. But you know what I'm talking about, right? Have you seen Spark or things like that use? Okay. All right. Well, see, yeah, if you live in a C or a Python world, you might not be as exposed to that. It's like the functional reactive stuff, where you combine monads and you can do it. So you take, I don't know, I don't want to go all into it. It's not, we could talk about it on the side. I mean, it's not necessarily.
This might be the first time someone's mentioned monads on the Hacker Hangout, an HTM Hacker Hangout.
Well, HTM.java that's what it works with.
With
that's
monads?
what its network API, yes. So you can take any output and combine it in any kind of way. So, and I mean, I could dress it up as a node, but it has, it inherits all this other functionality too. So, but it's real good for streaming stuff. But anyway, we talk about that any other time.
Congratulations to David Ray for mentioning monads. Here's your award. It's a spool of twine.
I want it delivered to my house too.
I'll mail it to you if you can describe what a monad is in 30 seconds.
Oh my God.
Not right now. I'll give you a month to think about it.
Oh, are you serious? No, because I found a great definition for it.
Okay, later.
Okay, all right. Right. But I mean, that's one of the hardest things to describe in the world. I mean, because you have to introduce concepts that are, that are tautological kind of, in a way. But anyway.
I think we're done. Who's smoke alarm? Is that our office smoke alarm still?
I think yes, and I think this is the first time it's gone off since the last Hacker Hangout.
Wow. I'm surprised it lasted a week without Jeff getting a ladder. He can't handle that type of distraction.
Why my face whenever that smoke alarm goes off? It's not important.
What is the coincidence between Hacker?
It was going on. The last time we had a hangout, there was a smoke alarm going off in the office.
Yeah,
and it's happening again, and it doesn't happen in between. I don't know.
And we've spent many hours since then, so I have no idea what's going on.
Right.
Anyway, thanks for watching the HTM Hackers Hangout 2016 year in review. And
Cortical.io was mentioned in The Economist.
yeah, that was pretty cool. Being mentioned in The Economist is cool.
Wow. Yeah, I mean, like a mainstream, respected, journal.
Yeah. So that's very cool. Congratulations, Cortical.io. Congrats, Nupit community, for another great year. I love all you guys. Take care. Have a wonderful 2017.
All right. See ya.
Cheers, guys.
Bye.